Welcome to DivRhino, a channel dedicated to project-based learning. I'm glad you're here. If you find these videos to be helpful, please like them and consider subscribing for more content. And if you've already subscribed, I appreciate you doing so. In this tutorial, we're going to use Go and a package called Maroto to create a simple PDF document consisting of a header and a table of products. We will also see how we can use randomly generated data for quick prototyping. To follow along, you will need to have Go installed. Inside VS Code, I'll ensure that I'm starting in my Sites folder. This is where I store all my code. Here we can create a new folder for our project. We'll call it Fruitful PDF because it will be filled with fruit. Then we can change into this directory. We will initialize Go modules to manage our dependencies. It is a good idea to name your package after the URL it can be downloaded from. This project will be available on my GitHub, so I'm going to use the repository URL as the name of my package. Please feel free to use your own URL for this step. Now we can move on to installing our dependencies. We will be using Maroto version 0.31.0. As of this recording, we also have to install the internal sub-package to get it working correctly. We will also install version 6 of the Go Fake-It package so that we can generate random data. If we take a look at the current contents of our project folder, we will notice that the go.mod and the go.sum files have been created. This means Go modules is working as expected. With setup out of the way, we can start writing code. Since this is a Go project, we will begin by creating a main.go file. Within main.go, let's set up package main and func main. Maroto has several sub-packages that provide functionality for a variety of things. To start off, let's install the PDF and constants packages. Then we can use these packages to create a new document instance. We want its orientation to be portrait and its size to be A4. Then we want to set the left margin to 20 units, the top margin to 10, and the right margin to 20. Our content isn't ready yet, but we can go ahead and save an empty file for now using the output file and close method. We want to save the output in a folder called PDFs. This folder does not exist yet, so let's create it. Output file and close returns an error, so let's do some quick error handling before we move on. If for whatever reason we are unable to output the PDF file, the program prints the error and immediately aborts. Let's import the OS package so we can use the exit function. It would be nice to have some feedback to let us know that something is happening. Let's print out a message every time our program runs successfully. If we run our program now, we will see that our success message prints in the terminal and an empty PDF file gets created in the PDFs folder. We can preview our PDF right inside VS Code by using an extension called PDF Preview. Now let's add some actual content to our PDF. We can start with the header. Let's create a new function called buildHeading that takes the document instance as its only argument. Maroto gives us a function called registerHeader. This allows us to create a global header for every page. The registerHeader method accepts an anonymous callback function as its only argument. This anonymous function can be thought of as a container. Inside the body of this container, we will add a row that has a height of 50 units. And then inside this row, we will add a full width column that spans 12 spaces. Rows are wrappers for columns, so we always begin with a row and add columns as child elements inside of it. Next, we're going to add a logo image to our header. Let's first create an images folder to store our logo. Then we can scroll up to import the props sub-package. I find it easy to copy the previous import and just change the name. Back in the registerHeader function, let's add a file image and pass in the path to our image. The second argument gives us a way to configure the image a little bit. We want the image to be centered, and we also want it to take up 75% of the container height. We should probably place our logo inside our images folder, so our program is able to find it. The file image function returns an error, so let's do some quick error handling before we move on. If the file is unable to load for whatever reason, we will print out an error message to the terminal. Next, we want to add some dark purple text to the header. We will need to import the color sub package to be able to work with colors. We will also need to create a new function called dark purple color. A color needs a red value, a green value, and a blue value. Let's go back to the build heading function and add a new row after register header. We will give this row a height of 10 units, and the column within it will take up 12 spaces, making it full width. Within this full width column, we can add a text element. The second argument of the text element allows us to add some properties. We want the text to be positioned 3 units from the top. We want the font style to be bold. It should be aligned to the center and have a text color of dark purple. And that completes our header. Let's make use of it by calling it from funcMain, making sure to pass in the document instance. Let's run our program now so we can preview our brand new header. In our PDF document, we can see our logo and the dark purple text we added. We've made it to our first milestone and you're doing great. Now let's keep going. We will start building our table of products by creating a new function called Build Fruit List. This function will also take the document instance as its only argument. We want our table header to have a teal colored background, so we can use the Set Background Color function to set the cell color to teal. We don't have a teal color yet, so let's create it in the same way we created our dark purple color. Back in our Build Fruit List function, we can add a new row that has a height of 10 units and a new column that spans 12 spaces. Then within the full width column, we can add a text element that will act as our table heading. We can give this text element some properties. We want it to be 2 units from the top, with a font size of 13, and a font color of white. We also want to set the font family to Courier with a bold style. And lastly, it should be aligned to the center. We're not finished with our product table yet, but let's take a look at what we've got so far. Let us first call our Build Fruit List function inside of funcMain. Then we can run our program in the terminal to generate a PDF. If we preview our PDF, we can see that our teal-colored table heading has rendered successfully. Now we can move on to creating the actual table of fruit. We want the main table color to be white, so let's change the background color from teal to white using the Set Background Color function. We can create a new table list that takes in table headings, content, and some properties as its 3 arguments. Let's store our table headings in a variable that will be of type slice of string. Our table headings will include fruit, description, and price. Let us also store our contents in a variable. The table list function expects the contents to be a 2-dimensional slice of string. This type will come up again when we generate our random data later, so keep it in mind. For now, let's just hard-code some dummy content. With table headings and dummy content in place, we can get our table elements set up. We will add some header props using the props table list content. It will have a font size of 9, and its grid sizes will be a slice of unsigned integers that add up to a total of 12. Here as well, the number 12 means that it is full width. We will add content props in the exact same way. We will align the table contents to the left and add a space of 1 unit to the header content. We don't want any lines between our table rows either. To improve readability, let's alternate the background color of our table rows by using the alternated background property. Let's make it a light purple color. We don't currently have this particular color just yet, but we can create it just like we created our other custom colors. And that's all we need for our table of products. If we run our program now, we can see that our table headings and table rows are rendered successfully. We've made it to our second milestone. Pat yourself on the back because you're doing awesome. In this next part of the tutorial, we're going to build a little random data generator using the Go Fake It package. To kick off this effort, we need to make a new directory for our data package. And within this data directory, let's create a products.go file. Let's open our new products.go file and indicate that it belongs to the data package. Next, we can import the Go Fake It package. Before we move on, let's take a look at the Go Fake It repository. We're interested in the functions. Go Fake It provides all sorts of functions for all kinds of random data. For this particular project, we're going to use lorem ipsum sentence, fruit, and price. You can go through the rest of the README later if you'd like to learn more about this package. Back in our projects.go file, let's represent the structure of our fruit using a struct. Each fruit will have a name that will be of type string, and we will have the fake fruit function applied to it. There will be a description that will be of type string, and we will have the fake lorem ipsum sentence function applied to it. We will also tell the function that we want 10 words in each random sentence. Finally, there will also be a price. This will be of type float64. This field will have the fake price function applied to it. We will tell the function that we want each price to be between 1 and 10. Now we can move on to generating random fruit. To achieve this, we can create a generate fruit function that returns a slice of string. Inside the body of the generate fruit function, let's create a variable named f that will be of type fruit. We can then pass f as a pointer to the GoFakeIt struct method. Then we will create a variable called fruit with 2 O's. This will be of type slice of string. To this we will append the randomly generated name, the randomly generated description, and the randomly generated price. The price is a float, so we need to use the sprintf from the format package to format it with 2 decimal places and convert the result to a string. Let's also be sure that the format package was imported correctly. Finally, we can return our fruit with 2 O's as a slice of string. If you recall, the table list method expects the contents to be in the form of a 2-dimensional slice of string. So let's create a public fruit list function that will return this 2-dimensional slice of string. This function will take in an argument called length. We can use this to determine how long we want our fruit list to be. Within the body of the fruit list function, let's set up a variable to hold all of our fruit. And let's also set up a for loop that we can use to generate a number of random fruit. For every iteration of the for loop, we will generate a new random fruit and append it to the fruits variable. And then we can return fruits as a 2-dimensional slice of string. And that's our little random fruit generator all done. Now we can head back into our main.go file and put it to use. First we should import our data package at the top of our file, and then we can scroll down to our build fruit list function and replace our hard-coded content with the call to the fruit list function. We want to generate 20 random fruit. If we run our program in the terminal now, we will see that our product list has been populated with randomly generated fruit data. We've made it to our third milestone. We got a lot done and you did a wonderful job. If you'd like to further extend this program, you can consider visiting the Moroto repository to learn more about all the other features it has to offer. For instance, you can experiment with adding a signature, a QR code, or even a barcode. You can also check out the various examples they have available. And speaking of examples, the code for this tutorial also comes with an example that implements all the features we pointed out from the Moroto documentation. And there you have it. In this tutorial, we learned how to create a simple PDF document using Go and the Maroto package. We also built a random data generator with the help of the Go Fake-It package. A text version of this tutorial can be found on divrhino.com, and a repo can be found on my GitHub account. I'll leave both links in the description for this video. If you enjoyed building this project, please like the video and subscribe to my channel. Thank you for watching.